Welcome back. Let's continue. Starting from the concept map, our first task is to identify and define quadrilaterals. The first one is a rectangle, and a rectangle has all angles are equal to 90 degrees. I think we usually see them with a small box at the corner. That small box represents 90 degrees, that's a right angle. And the next point on identifying and defining a rectangle is that the opposite sides are parallel and equal. Opposite sides means PS and QR, they are facing each other, so they are opposite. And the fact that they are parallel, you would see they have an arrowhead that is the same. So if it's a single arrowhead, those two are the ones that are parallel. And if it has a double arrowhead, then those are the ones that are parallel as well. So in this case, opposite sides, PS and QR are parallel, and then PQ and SR are also parallel. And that's the first part, that means parallel, and then the opposite sides are also equal. Then we look at the next marking, which is a line. Look at that singular. Let's use a different color here so that you'd see it differently. There is a single line there and a single line there. That marking and that marking means that, that marking and that marking means that these two sides are equal, and therefore this one also shows that these opposite sides are equal. So now we know that the opposite sides are parallel and equal in terms of a rectangle. The next one is a parallelogram. Parallelogram has two pairs of angles that are equal. So two pairs of equal angles. Let's look at that, and you'd see that this one has a similar marking with that one. So those two angles make the first pair, and these ones also have the similar marking, so they therefore make the second pair. So the two pairs of opposite angles are equal, and then equal angles are opposite to each other, which means that one is facing that way and the one is facing the other way. Therefore, those angles are opposite. And then opposite sides of parallel are parallel and equal. Again, opposite sides are parallel, so we now know that AD is opposite BC, and similar marking means that they are parallel, as well as AB and CD. They also have a single arrowhead, which means they are also parallel. And then we look at the fact that they are also equal, and we're looking at those markings that we were showing. There are two double line there and a double line there, which shows that those sides are then equal. And here we have a single line on this side and a single line on the opposite side. So those sides are also equal to one another. Let's look at the next diagram, which is a square. A square has all sides equal. Let's look at the markings. Do they prove that? And do they show the same thing? We have four sides, and all four sides have a same marking of a single line, which means all those four sides are equal to one another, and the angles are equal to 90 degrees. As you can see, there is a square that proves at the vertices that the angle is 90 degrees, and all the angles are all equal to 90 degrees. Let's look at the next one. And that one is a rhombus. Rhombus sides are equal as well. So it's similar to a square. It has four equal sides, or all sides equal. But then the pairs of opposite angles are equal, which means the shape does not have 90 degrees, but then it has that angle opposite to that one, and they have the similar marking that makes them equal, and the other two are also forming a pair. So the pair of opposite angles are equal. Let's move on to the next one, which is a trapezium. Trapezium has one pair of opposite sides which are parallel. And in this case, we would see that with those arrowheads, that WX and YZ are parallel because they have one arrowhead. The other sides are not parallel. Right, let's look at the next one. The next one is a kite. And with the kite, we have two pairs of adjacent sides that are equal. Let's look at the shape of a kite, and you would see that when we say adjacent, adjacent means those two sides are joined together. So in this case, we're looking at that side and that side. Those are the ones that are joined together. And when you look at them, they have a marking that is the same, and therefore that makes those two sides to be equal. And then the other two sides are also equal because they have a similar marking. And therefore the two pairs, that would be the first pair at the top there, and the bottom would have the next pair. And those sides are equal. Then one pair of opposite angles is equal. Let's look at the opposite angles. Let's look at the next segment of our concept map, which is now the sum of interior angles of a quadrilateral. JKLM is a quadrilateral, and there we are given that we are firstly to measure the size of all the angles and then draw a conclusion. What is your conclusion about the sum of the angles? So let's do that practically so that you'd understand just remind you how to measure it, and then we take it from there. So let's do that practically. All right, as we measure, let's start with angle J. I'm only going to measure 2 just for the convenience of time. When we're measuring from the top, the protractor faces downwards. So in this case, as you can see, angle J equals to 89 degrees. And then let's look at the next one, how it's going to be. When we're measuring from the bottom, angle M, we're placing it, the protractor then is facing upwards, and we're measuring from right to left, and it gives us 94 degrees. And the other two angles gave us 96 and 81. Okay, let's write them in. This is angle 89 degrees. This is angle 94 degrees. And this is angle 96 degrees. And this is angle 81 degrees. And when you add all of them, it would be 89 degrees plus 96 degrees plus 94 degrees plus 81 degrees. And that should give you 360. So we have measured, and that is now our conclusion, that angles of a angles of a quadrilateral, sum of angles. Sum meaning the addition of angles of a quadrilateral equals 360 degrees. So that is our conclusion because that's what we have done. However, you don't always have to rely only on the ruler, because we need to prove that these angles are 360. So let's use a different method. Let's say you don't have a protractor, but then the task still needs to be done. Let's look at the sum. Then the next question, ABCD is a quadrilateral. Draw your own on a piece of paper, which means as we go along, you can also draw your own and do this exercise. You use your own size of angles, you use your own size of lengths of lines. However, measure the size of all the angles. You can verify them and then mark all the angles, which is what we have done, A, B, C, and D. And then cut out the marked angles. So for now, let's stop there and then do that practically so that you're able to see how we are going to do this measurement without using a protractor, so that you're able to see that it is true that the angles of a quadrilateral equals to 360 degrees. So let's do a practical task of this. We have our quadrilateral ABCD, and we were tasked to mark the angles. So I've marked the angles A, B, C, and D, and then we were then tasked to also cut them out. So you take your scissor and you cut out the marked angles, and this is what they would appear like without the marked angles. There are our marked angles, all 4 of them, and then number D said join the cut pieces, and what do we notice? So we'll join them, and as we join them together, we notice that they form a revolution, and a revolution is 360 degrees. I hope you noticed how to measure those angles on your own, and the more you practice, the better you'd be. And then the conclusion, let's look at the conclusion together. I'm using another quad because it doesn't mean that it's only that quad that equals to 360. And this one is a rectangle. And as you know that the angles of a rectangle are 90 degrees, and 90 multiplied by 4 would give us 360. So when we add them, we get that. And so just to remind you that the angles, all the angles are equal, and each angle is equal to 90 degrees. Therefore, the sum of interior angles of a quadrilateral is equal to 360 degrees. So now we are convinced, we know that this is not thumbsucked. We have worked at it and we have seen it for ourselves. Let's look at a typical question in this section, and in terms of sum of interior angles. Here's a question. PQRS is a quadrilateral. Angle P is 97, equals to 97 degrees, and angle Q equals to 83 degrees. And we are asked to determine the sum of all the angles. That means we are now to add all the 4 angles. Remember the signs that are in the marking. If P and R have the same marking, that means they are equal, and therefore we use the same number. So it's going to be 97 plus 83 degrees plus 97 degrees plus 83 degrees. This is the sum of all the angles of that quad, and which would give us 360 degrees. So when we add them, we know that these that are equal, we use the same number. The same value of the angle. Then what is the name of this quadrilateral? Look at it again and see it has parallel sides that are opposite. It doesn't have 90 degrees, and therefore it's a parallelogram. So that is a parallelogram, because the angles, none of the angles is 90 degrees, and the opposite angles are equal, because opposite angles are equal and the sides are parallel. Opposite sides are parallel. Let's look at another question in this regard. ABCD is a quadrilateral. BD is a diagonal line. Angle DBC, let's look at it. D, starting from DB to C, that angle there equals to 42 degrees, and angle C equals to 96 degrees. And let's look at the question. We are to calculate the size of angle ADB. So it's angle ADB. So that is the angle we are to calculate. Look at what is happening there. This sign says these 2 lines are parallel. What do we know about parallel lines and angles that are forming a Z shape, or angles between 2 parallel lines that are on the other side of the transversal? They are equal because they are alternate angles. So because of AD and BC being parallel, so we then say angle ADB is equals to 42 degrees because it is an alternate angle to DBC, and that is caused by AB being parallel to BC. So that is why that angle equals to 42 degrees. Let's move on to the next part. Add all angles together and what can you conclude? And let's add all of them together. Look at the angles. So now that one is 42 degrees and that is 96. The opposite angle to that would also be 96 because this is a parallelogram. These sides are parallel and all sides are equal. And look at that. And if that is 42 and that is 96, when you add the two of them, you'll find out this one is also 42. These are parallel, these are equal sides. So the angles opposite the equal sides are equal. So it's 42 degrees, and that one is also 42 degrees. So when we add the angles, which would be angle A plus angle B plus angle C plus angle D, the values would be 96 degrees plus 84 degrees plus 96 degrees plus 84 degrees. Then let's add them together. 96 plus 84 would give us 180. So it would be 180 plus 180. So that would give us 360. And therefore, so when we add angle A, B, C, and D, which is all the angles of a quadrilateral, we get 360. Then we can conclude, as we are asked to conclude, that the angles of a quadrilateral, the sum of angles of a quadrilateral, would be equals to 360 degrees. That is now our conclusion. Let's move on to the next one. The next question is, PQR is a quadrilateral. Determine the size of the angles by solving for x. Let's look at that question together. What do we know about a quadrilateral? We've just proven that the interior angles of a quadrilateral will be equal to 360. So that means we can add all these angles, which is 2x plus x plus 30 degrees plus x plus 50 degrees plus 80 degrees, and we know that they will be equals to 360 because they are interior angles of a quad. And then we add the x's together. There's an x there, and x there. So 2x plus x is 4x. And then we have three angles as well, 30 degrees, 50 degrees, and 80 degrees, which when we add would give us 160 degrees, which equals to 360. And then additive inverse of 160 is negative 160. So it would be 4x plus 160 degrees minus 160 degrees, which equals to 360 degrees minus 160 degrees again. And therefore, on the left, 160 degrees minus 160 would leave us with 4x. And on the right, 360 degrees minus 160 degrees would give us 200 degrees. And then the multiplicative inverse of 4 is a quarter. Therefore, we divide by 4 on the left and divide by 4 on the right. And then 4 divided by 4 gives us x, or leaves us with x, and 200 degrees divided by 4 would give us 50 degrees. So our value of x is 50 degrees. Go back to the diagram. 2x means that it's 2 times 50, which is 100 degrees. And then value of angle S, 50 plus 30 is 80 degrees. And then angle R, 50 plus 50 is 100 degrees. And so we are now able to see all the angles. So when we look at those angles, you'd see that angle P and angle R are equal and opposite to one another. And angle Q and angle S are also 80 degrees each, so they are also opposite to one another. When you look at that, you would see that a quadrilateral that has opposite angles that are equal would then be a parallelogram. Parallelogram. That is the second question, which is the name of the quad. So it's a parallelogram. Okay, let's stop there for now and go for an ad break. See you shortly.